Welcome to FNM Labs. We continue our 8th grade maths topics. In this session, we will begin with a new topic called exponents. We will see what are exponents, what is its significance. Then we will talk about 3 basic rules related to exponents. And also we will discuss a couple of important points that will help simplify things in the learning process. Finally, we will do a number of practice problems in the next 2 sessions in separate videos. That being said, let us move straight away to the topic. In former classes where we studied multiplication, we had seen that multiplication is nothing but repeated addition. For example, 5 plus 5 plus 5 is equal to 3 into 5. That was repeated addition of 5 3 times. Now what about repeated multiplication then? Say 5 into 5 into 5. Here comes the idea of exponents. We denote the above product by writing 3 on top of 5. This special notation is known as exponential expression. Here 5 is called the base and 3 is known as the exponent or power or index. The above expression is read as 5 raised to the power 3 or simply 5 raised to 3. 2 raised to 4 and 10 raised to 5 are other examples. Suppose we introduce 2 variables, x for any number and n for any integer. Assume that we multiply x n times. Based on the notation we just got introduced, this can be written as x raised to n. This is a general exponential expression. If we assign 10 to x and 5 to n, this expression becomes 10 raised to 5. Now you know what are exponents. Adopting the new notation to express repeated multiplication, we could simplify writing lengthy multiplications. Now the question is, can we do basic mathematical operations like multiplication or division involving the numbers expressed exponentially? Here comes a couple of laws to guide us. So now it's time to see some of the laws and guidelines. There are 3 basic laws. They are product law, quotient law, and power law. Let us now discuss the product law. If m and n are integers and a is any number, then a raised to m into a raised to n is equal to a raised to m plus n. This means when you multiply more than one exponential number with the same base, you just can add the powers. For example, 5 cube into 5 square is equal to 5 raised to 5. 6 square into 6 raised to 3 is equal to 6 raised to 6. Remember, 6 is same as 6 raised to 1. Any number raised to 1 is same as the number itself. In the definition, why do we use the term m and n as integers? We will see it shortly. The second law we will see is the quotient law. It says if m and n are integers and a is any number, then a raised to m divided by a raised to n is equal to a raised to m minus n when m is greater than n, and it is 1 by a raised to n minus m when n is greater than m. For example, 2 raised to 9 divided by 2 raised to 4 is equal to 2 raised to 5. And this is an example when the power in the numerator is greater than the power in the denominator. Another example is 7 square by 7 raised to 5 is equal to 1 by 7 raised to 3. In this case, the power in the denominator is more than power in the numerator. By the way, I hope you might have noticed that if the power of the numerator is bigger, then the quotient will be in the numerator. And if power in the denominator is bigger, the quotient will be in the denominator. Consider 7 square by 7 raised to 5. Here, as per the definition, normally it is expected to use the second form as n is greater than m. But are you curious enough to think what will happen if we use the first form instead? Yes? Let's try it. Here 7 square by 7 raised to 5 results in 7 raised to 2 minus 5. That is equal to 7 raised to minus 3. And soon we will see that a negative power means its reciprocal. That means this is equal to 1 by 7 raised to 3, and which is the same result as we obtained applying the second form. So both the forms are the same. Next we will see the power law. If m and n are integers and a is any number, then a raised to m whole raised to n is equal to a raised to m into n. This implies that if a number raised to a power, which is again raised to another power, and so on, it is same as the number raised to the product of the powers. For example, 8 raised to 3, which again raised to 2, is equal to 8 raised to 3 into 2. That is 8 raised to 6. In the same manner, 2 raised to negative 4 whole raised to 3 is equal to 2 raised to negative 4 into 3. That is equal to 2 raised to negative 12. So far, we saw raising a positive number to some power. What if we take power of a negative number? Let's take a negative number, say negative 3, and raise it to different positive powers and see the values. Negative 3 raised to 2, that is negative 3 square, is negative 3 into negative 3, that is equal to 9. Its third power, that is negative 3 cube, is negative 3 into negative 3 into negative 3, that is same as negative 27. Its fourth power, that is negative 3 raised to 4, which is multiplying itself 4 times, is equal to 81. Fifth power of negative 3 is negative 243. If we closely observe the different powers of negative 3 and their values, we can see that all the even powers of negative 3 results in positive value. Here they are negative 3 square, which is 9, and negative 3 raised to 4, which is positive 81. Also, all the odd powers of negative 3 gives negative results. Example, negative 3 raised to 3, which is negative 27, and negative 3 raised to 5, which is negative 243. So we come to the conclusion that if n is even, negative 3 raised to n is positive, and if n is odd, negative 3 raised to n is negative. In general, if a is any number and n is an integer, then if n is even, negative a raised to n is same as a raised to n. And if n is odd, negative a raised to n is same as negative of a raised to n. That was positive exponent of a negative number. Interestingly, what will be the negative exponent of a number? If n is a non-zero rational number, a raised to negative n is equal to 1 by a raised to n, and a raised to n is equal to 1 by a raised to negative n. In other words, a raised to n and a raised to minus n are reciprocals to each other. We already have seen what are reciprocals in a previous session. For example, 4 raised to negative 2 is equal to 1 by 4 raised to 2. 9 raised to 3 can be written as 1 by 9 raised to negative 3. Can you say what will be 2 by 3 raised to negative 2? Negative power of the fraction is 1 by positive power of the fraction. So 2 by 3 raised to negative 2 is equal to 1 by 2 by 3 raised to positive 2. This is a division by fraction. This can be made to a multiplication using the reciprocal of the fraction. Therefore, 1 by 2 by 3 square can be written as 1 into 3 by 2 square, which is simply 3 by 2 square. Let us recapitulate the points we covered. We have seen 3 rules that help us to find the product, quotient, and powers of numbers represented in exponential form with the same base. We then saw the nature of positive power of negative number. The value will be positive when power is even and negative when the power is odd. We also saw the negative power of a positive number, which is nothing but the reciprocal of the positive power of the number. Let us keep these simple rules in mind. That will be very helpful as we proceed further. Remember to take enough time to understand these basic ideas thoroughly to avoid possible confusion in the future. Now let us see a couple of key points which are worth to be noted. I would recommend to give special attention to these as will be of great help in solving problems. The first one is division by a number or a fraction is same as multiplication by its reciprocal. Reciprocal of a number, say 4, is 1 by 4. Similarly, reciprocal of a fraction, that is 2 by 3, is 3 by 2. Suppose we divide the fraction 2 by 3 by 4 by 5. This division may be converted to multiplication by using the reciprocal of the divisor. So this becomes 2 by 3 into 5 by 4, which is again equal to 2 into 5 divided by 3 into 4, which is equal to 10 by 12. Another example is 1 divided by 1 by 4. Dividing 1 by 1 by 4 is same as multiplying 1 with reciprocal of 1 by 4. So it becomes 1 times 4, that is equal to 4. Another example is 1 by 4 divided by 2. This becomes 1 by 4 into reciprocal of 2, which is 1 by 2. So the value becomes 1 by 4 into 1 by 2, which is equal to 1 by 4 into 2, which is 1 by 8. Previously, we discussed about negative power of a positive number and a positive power of a negative number. Now, what about the negative power of a negative number? Consider negative 2 raised to negative 3. First, take the negative power. We saw it is reciprocal of the number with a positive power. So the expression becomes 1 by negative 2 raised to 3. We also know that odd power of a negative number is negative. Here 3 is odd. Since 2 cube is 8, this value becomes negative 1 by 8. Similarly, negative 2 raised to negative 4 becomes 1 by negative 2 raised to 4. Since even power of a negative number is always positive, this may be written as 1 by 2 raised to 4, that is equal to 1 by 16, as 2 raised to 4 is 16. Another example is 1 by 5 raised to negative 2, which equals 1 into 5 raised to 2, that's again equal to 25. Third point, which is worth to be noted, is a fraction power of a number. What does that mean? For example, consider 2 raised to negative half. Is this equal to 1 divided by 2 raised to 2? No. It is equal to 1 by 2 raised to half. Now, a number raised to half is the square root of that number. Thus, the value becomes 1 by square root of 2. What is 2 by 3 raised to negative 3 by 5? Remember that negative power of a number is positive power of its reciprocal. Hence, this value becomes 3 by 2 raised to 3 by 5. Further, keep in mind that a times b all raised to n is same as a raised to n times b raised to n. In the same manner, a divided by b raised to n is equal to a raised to n divided by b raised to n. For example, 3 times 4 whole square is same as 3 square times 4 square, and 2 by 3 whole raised to 4 is equal to 2 raised to 4 by 3 raised to 4. So far, we were discussing about the essence of exponents. We now know the exponents are about repeated multiplication. We examined 3 basic laws on exponents and how to simplify products, quotients, and powers involving exponential expressions. Now, the next step is to apply this information to solve problems on exponents. We will do this in next 2 videos, Exponents Practice 1 and 2. So meet you in the next video. Till then, have a great fun with mathematics.